Okay, so that was day 4 of this workshop. Hopefully we are all now in a position where we're ready to begin the final section, which will be largely working in a team on a shared repository. So a bit of a different format we'll have tomorrow. If you do have any bits that you didn't quite get to finishing, don't worry about it too much. Tomorrow, when we form those teams, we'll be picking, or you will be picking, one repository to be your group's repository. So feel free to pick any of them within your group. It doesn't have to be the best, it doesn't have to be the worst. And the idea is just that one of the other teams will review that repository, raise some issues, and then you can spend some of the session working through those issues, prioritizing them and resolving them in a mini sprint at the end. I've had a look at the team's organization document, and again, this is mostly for those who are watching this as a recording. I've posted a message in Slack to this effect as well, but if you are not joining us actually in these Zoom calls, please could you make sure you've put yourself on that team's organization spreadsheet. Could you also do that if you have a specific team that you want to work with, even if you are joining the Zoom call, so that you can put yourself with that team and we don't keep you in one of the breakout rooms that you didn't need to be in anymore. If you are working remotely and not joining us in these calls, could you please, basically as soon as possible, as soon as is reasonable, decide which of your repositories you're going to use in that team and add the URL to your GitHub repository in that document as well. So what will happen then is that one of the instructors will come and review your code either tonight or tomorrow morning, as it is in our time zone, so that you have some issues logged ready for when you begin. Particularly that will be relevant for people to the east of us, and because you'll be starting before we start the workshop. So if you're not joining these Zoom calls, please pick a repository for your team, and I or one of the other instructors will review that for you so it's ready for you. That means we don't have to try and synchronize you with one of the other teams. If you are joining the Zoom call on Friday, then if you have a preference for a team that you have from an existing project or something, that's fine. You can go with them. We will make more breakout rooms on Friday, so you can split up as you wish. If you don't have a particular team and you're here on Friday, you can just stay with the breakout room you've been with this week. That'll be fine. And for the people who are here on Friday, we'll arrange the repo swaps between pairs of teams just as you are ready. So when you get to the bit where you're ready for that, we'll swap you with whoever else is ready at the time. So we'll arrange that on the day. Don't have to worry about that. Does anyone have any questions then, either procedural questions about anything that's happened so far or for Friday, or any questions about the material of the sections we've seen so far? Or any interesting discussions we've had in groups that people want to share?
A very small question, I guess. I've noticed that you use Lambda functions, especially when you were talking about functional programming, etc. And I recall that Pepe discourages Lambda function. Is it something that is still used nonetheless, specifically when functional programming and with MapReduce to simplify things, and we ignore the Pepe recommendation? Is that okay?
I wasn't actually aware that they recommended against Lambda functions entirely. I will have a look at that myself to see the specific wording of it. They definitely have a place. They are, in my opinion, they're useful if the function is just a single statement. And so at the very simplest case, lambda's like add one, and you don't want to have to write an add one function, so make a lambda for that.
I don't disagree. I'm quite happy to see them.
Yeah. But certainly anything much more complex than that, make it a normal function. In Python, lambdas are limited to a single expression. So you can't have much more complex lambdas than that. In some other languages like C++, you can have arbitrarily complex lambda functions. But in Python, we're forced to keep them quite simple, and I think that's a good thing. Rose, you had a question as well.
Yeah, could you explain the serializer class again? And when you have these abstract classes that aren't doing anything, you know what I mean, where all the methods weren't implemented. Could you explain again a little bit what those are for? I tried reading it a few times, but it's not clicking, I think.
So the purpose and the consequences of an abstract class is that.
Say that again. Well, where we made the observation and then made it a subclass or whatever of serializer. But the actual class we added didn't have any implemented functions.
So particularly with the abstract classes specifically, where we got on that towards the end, abstract classes are really sort of a template or a contract by which we expect other classes to behave. So where we did that towards the end, and really actually most of the inheritance tree towards the end, are things at the top of the inheritance tree, the things we don't use directly, like the abstract classes, are templates for or contracts for the concept of a serializer. So if we are to have a class which serializes some data, these are the things it must do. The purpose of that are about fixing our expectations of a serializer, in that once we've said these are the methods that any serializer must have, we can then use any serializer in our code because we know what the interface looks like. We know what functions we have to call to have a particular consequence happen. But it also means we can write a serializer for anything because we know, okay, if I'm doing a serializer, it has to have this thing and it has to have this thing. And these are what these methods have to do. So it becomes much easier to write a serializer for something else if you have that contract of what a serializer looks like. If we go down the inheritance tree a little bit, where we had, say we had a patient serializer, and then inherit from that, we have a patient JSON serializer and a patient CSV serializer and a whatever else. In each level we go down that tree, we're getting a bit more specific. So at the very top, we've got, okay, this is what a serializer looks like. Any serializer must have these properties. The next level, we've got, okay, any serializer which serializes patients has to do this. And particularly that's useful because we know that any serializer which serializes patients, the serialize method will always take a patient or a list of patients, and the deserialize method will always return a patient or a list of patients. So we can guarantee that at that level. And then at the very bottom level, we've got our patient JSON serializer, which is the actual concrete implementation of that class, where this is an actual thing that actually serializes a patient into and from JSON. that's the most specific we get because it's where the actual code that does that lives. So it's all about levels of specificity, because we may want to add an alternative implementation for something at some point. Does that answer the question? That there may be some aspects I've missed there, but
No, yeah, that's great. And so it's not necessarily like if you had a class that was inheriting the base serializer that didn't have those functions, does it throw an error, or it's just like it's there as a guide of what you should be doing, not necessarily what you have to do?
So that's one of the utilities of abstract classes. In many other languages, so if we take Java, for example, Java forces you to respect that contract because it has a type system around interfaces, Java calls them, that guarantees that the functionality will exist if you say it exists. Python doesn't have that level of guarantee unless we're using abstract classes, because when you subclass, when you inherit from an abstract class, you must define an implementation for every abstract method. It won't let you construct an instance of a class that has any abstract methods remaining. So I quite like abstract classes because it forces us to think about that. If you are creating a subclass of something that doesn't have some of the behavior or some of the properties of the parent class, that isn't really a subclass of that. It's not the same type of thing. So what we're saying when we build a hierarchy is we're saying that a patient serializer is a serializer. If a patient serializer didn't have, for example, the serialize method, it's not a serializer, and it's not semantically meaningful to say that that is a serializer, because it's just not. It's a different type of thing. However, Python doesn't catch that unless you've made the one above an abstract class. Rachel, you had a question as well, or a thought?
In fact, following on from Rose's question, if I understand you correctly, then if you have an abstract class which has all the class methods defined, if you then use that abstract class in a superclass, then you have you can have additional methods. You have to have the base set, but you can also add additional methods that are specific to whatever function it's performing.
Yes, that's right. So where I was shaking my head there, I thought we were going down the if you try to create an instance of an abstract class and you just can't create an instance of an abstract class, it doesn't let you.
Right, but if you
yes,
use it as a superclass in an inherited class, that works.
Yes, when you subclass something, you can add any additional behaviors you want, and you can modify what an existing behavior does, but you can't subtract behaviors. That's not meaningful to do. So one of the examples that's used, like way overused in teaching object-oriented programming, and it's actually a really bad example, is you can create inheritance trees of animals and things, and you have I can't think of an example actually that illustrates what we're trying to say, or where you might add a behavior. No, sorry, I didn't know where that train of thought was going.
Okay.
That train of thought
I can think of
derailed.
an instance, if I may, just to propose and see if this is appropriate. In astronomy, for example, if you were ingesting data, comes in many different formats, could come in a CSV file, could come in a FITS table, could even come from a TAP query, for example. And I can well imagine having a serializer that uses an abstract serial class and then has a superclass for each of those different data types. And that would be a good use for this construct, yes?
Yes, however, terminology, I think that would be a subclass. The superclass is the parent, the subclass is the child at the bottom of the tree.
Got it.
But yes, yeah, you would have a subclass for each type of file you want to serialize, and they may have different things. Some of them might need a unit transformation or something, but not all of them need.
Right, exactly. You could imagine having additional class methods on the child class for example, handling columns in a AstroPy table, for example.
Yeah, absolutely.
Yeah.
That would be a good use of that.
That makes sense. Thank you for explaining that. Great question, Rose.
It was a very good question. Does anyone else have any questions? I know we've kept you a little bit late already. No, in that case, I would like to just ask a single question via Zoom reactions, and we won't bother with the whole set. Could I ask people to use a thumbs up or a tick or some sort of positive response if they made it through any of the extra material, if they went into the extra material and made it through that? This is just interest as to how many people took that route. Okay, a few. So it is worth that extra material existing then. That's good. Okay. In that case, I don't have anything else I need to say, I think. So do we have anything else we need to say from a procedural perspective, other than thank you everyone for joining us again, and we'll see you tomorrow. And thank you to all our instructors once again. Very valuable session. And we'll see everybody again, same time, same Zoom meeting tomorrow. Bye, everyone. Thanks, everybody.
Bye.
Bye-bye.